Hi, I am Alperen. This is our physics project in the semester, 212 physics project. Actually, we measure the most fundamental things in the physics, a Planck constant. With the four equipment, actually, LEDs, power supply, of course, and diffraction grating, and a webcam. That's all. I just want to announce our results in the beginning of the video with the paper, of course. Our final value is the 7.00 times 10 to the minus 34 joule-seconds. The accepted value is the 6.626. So we are within the 5.7%. It's actually accurate results for in the school equipments. You can see our graph in there. The idea is coming from one of the greatest physicists in the world, the Albert Einstein, and the photon of the light. The photon carries an energy equals to h times its frequency. When you slowly raise the voltage on the LED at some threshold value, the lights glow up. At this point, the electrical energy is converted into the one photon. This gives us a simple linear equation. V0 equals AC over A times 1 over lambda. So if we measure the threshold voltage for the several LEDs of different colors and plot V0 against 1 over lambda, we get straight line. The slope of that line multiplied by the E over C, this is a Planck constant. You can see our graph. Again, our experiment has two halves. First part is electrical and second part is optical. In the first part, in the electrical part, we measure the LED's threshold values. And second part, we measure the wavelength of the H LEDs from our homemade spectrometer. Then we combine the two and read the H from the slope. In the electrical part, we try to find H slope from the given wavelengths, its expected value. But after that, we try to find wavelengths of the light from our homemade spectrometer. Actually, we have the three parts in the LED's power supply and resistor. We try to find when the LEDs shine on, and after the LEDs shine on, we write the voltage value at the time. It's the threshold value of the LED. Actually, you can see our results in there. For the wavelengths in the second part of our experiment, we built a spectrometer. You can see our setup. It is in the show box lined with the black paper and a rough slit cut from the cardstock. You can see a little near stick split. 1000 per millimeter diffraction grating and Logitech webcam. In shortly, there is a split. You can see the light behind the paper, and it is so small. There's a grating, and when you see this light, it is in the 0th degree, and the diffraction grating plane is diffract the light in some points. With our Python programs, we just measure the distance between them, and we try to find wavelength of the light because different wavelengths has different diffraction distance. And because camera and grating slits is very close to the camera, simple screen distance formula doesn't work in it or work. So we let the camera focal length in pixels be number that absorb the all geometry. We measure it from the red green and blue. You can see our photos in there. There's three lines. First line from its light and others from the grating. We measure that point's distance and we try to find wavelength of the light. Putting all together, we plot V0 against the 1 over lambda for the four LEDs. As a straight line you can see in the graph. This slope is 1.310 times 10 to the minus 6 volt meters. Multiplying with some constants, we get the Planck constant equal to 7.00 plus or minus 0.37 with the experimental error. The main remaining limitation is that we measure the light's threshold value with our eyes. It can be more accurate from the some technical equipment. We found 5.7% above the accepted value. Thank you for listening. Thank you.